Hello everyone. In this video we're gonna derive the expressions for the tangential and centripetal accelerations. As an introduction, what is kinematics? Study of motion without taking into consideration its causes forces. We study the motion of a given object by finding its position, velocity and acceleration. Our objective is to find position, velocity and acceleration of a given object. Now, to do this, what do we need? We need tools, and these tools are space reference and time reference. Examples on space reference: the Cartesian plane and FRENET-SERRET or tangential normal plane. These two planes enables us to find the position, and from position we can find the velocity and acceleration. First situation: motion of a particle in the Cartesian plane. An object M or a particle M is moving along a given trajectory. The Cartesian plane or XY system is formed of two axes, a horizontal axis and a vertical axis. I and J are two unit vectors oriented respectively along X and Y. At any instant, M has coordinates X and Y, so we can write the position vector of M as R vector equals to xi plus yj. Now, from R, we can find the velocity and the acceleration of the object by deriving R. The velocity is rate of change of R with respect to time, and acceleration is rate of change of v with respect to time, mathematically the derivative of v with respect to time. Now, v and a both have two components. Vx and Vy are the components of v in the Cartesian plane, and Ax and Ay are the components of A in the Cartesian plane. Now, motion of a particle in FRENET-SERRET plane. First of all, some information about this plane. A particle P is moving along a given path or trajectory or a given curve. How to draw this plane? The object, we need to find the velocity and acceleration at the point P. First, we need to draw this plane. This plane is formed of two axes, T, the tangential axis, and N, the normal axis. Now, we can approximate this curve at P or near to P by a circle called the oscillating circle. This circle has a center I, which is called the center of curvature, and R, radius of curvature. The tangential axis is drawn tangent to the trajectory and pointing in the direction of motion. The normal axis is perpendicular to the tangential axis and pointed towards the center of curvature I. The two unit vectors are ut and un. Ut is a tangential unit vector tangent to the curve and pointing in the direction of motion. Un is a normal unit vector perpendicular to the tangential unit vector and pointing into the center of curvature. The radius of this circle is the radius of curvature. This circle is the best approximation of the curve near P. The relation between ut and un is the derivative of ut with respect to us is equals to kun equals 1 over run. K is called the curvature. We will prove this relation. Dut by ds is an arc length. An object is moving along a given trajectory. The object moves from a given point, for example M1, to a point M2. ds represents the arc length. ut1 and ut2 are the tangential unit vectors required to prove dut by ds equals kun. Step 1, we need to verify that dut by ds, this vector, and un are collinear. Now, we know that ut.ut equals to 1. We derive both sides with respect to us. Therefore, u prime v plus v prime u dut by ds times ut plus ut times dut by ds. We know that the scalar product is commutative. Therefore, 2ut dut by ds equals 0. Therefore, ut and dut by ds are perpendicular. We know that ut and un, the tangential and normal unit vectors, are perpendicular. Ut perpendicular to dut by ds, and ut is perpendicular to un. Therefore, dut by ds and un are collinear. Step 1. Step 2. Our objective is to verify that this constant k is equal to 1 over r. Now, dut equals to ut minus u1. We translate ut1 to this point and we reverse its direction. Dut d theta represents the angular displacement. Now, by using the geometry of the figure, this angle d theta is equals to the angle between ut and minus ut1. Now, by using this right triangle, sine d theta equals to opposite length of dut divided by the hypotenuse, which is ut1, norm of ut1. Small angle approximation, sine d theta is equal to theta. ut1 is a unit vector. Its magnitude is 1. Therefore, dut is equal to d theta. Now, dut by ds equals to d theta by ds. We know that the length of the arc is equal to the angle multiplied by the radius. ds equals to r d theta. Therefore, d theta by ds equals to 1 over r. Therefore, dut by ds equals to k un equals to 1 over r un. Now, the velocity vector in Frenet system. We know that the velocity vector is tangent to trajectory, so it's oriented only along the axis t. V vector equal vut, where v is an instantaneous speed. We know that speed average is equal to distance divided by time. The instantaneous speed, the distance covered, is ds divided by the duration dt. V equals to ds divided by dt. Now, the acceleration is equal to the derivative of v with respect to t. Therefore, dv vector by dt equals d of vut by dt. Now we apply the rule u dot v equal u prime v plus v prime u equals dv by dt times ut plus v times dut by dt. Now we apply chain rule. The first term is here. We apply the chain rule. V dut by dt equals to dut by ds times ds by dt. We said that ds by dt, the arc length, it represents the distance covered by the object divided by time. The duration is v. ds by dt is v. And this is verified. Dut by ds is equal to 1 over r un. A equals dv by dt ut plus v. We said that dut by ds is 1 over r un, and ds by dt equals to v equals to dv by dt ut plus v squared over r un. Now, at, the tangential acceleration, is the derivative of speed with respect to time, and an is v squared over r. At and an, the tangential and normal or centripetal acceleration, are the components of A in FRENET-SERRET plane. Tangential acceleration is change in speed, and normal or centripetal acceleration is acceleration generated due to change in direction of velocity. Thank you.